This video will cover Chapter 1, Section 4. In this video, we're going to focus on data types and how to categorize data. This is going to be important later on when we're trying to decide which statistical techniques to use to analyze the data that we've collected. Something that's not in the book. The idea of where the data come from. Primary versus secondary data. This is actually important because primary and secondary data come from different sources and have different issues when you collect them. So primary data is data that you collect yourself, or the company collects itself. So we've talked about these things: observation, experiment, survey, those kinds of things where the company actually engages in collecting the data. That's primary data because the companies collected the data themselves. Secondary data can often be very useful in analyzing things that you're looking at. But secondary data is data that somebody else collected, and you're now going to use that data to say something useful. So secondary data could be something like the unemployment rate. The government collects that information. They publish that electronically so that you can get your hands on that. You might use that to try to make some analysis of the demand for your product coming up in the future. If there are a lot of people unemployed, they're probably not going to be buying a lot of cars. That could be used to make that analysis. So we've got primary data, data that you collect yourself; secondary data, data that somebody else collected and you've downloaded it or found it printed somewhere. The book provides this picture for you to summarize the ways that we categorize data. So we categorize data based on data timing. Timing can be either over time, that's time series, we'll talk about that more in a minute, or cross-sectional at a given point in time. There's the data types, qualitative versus quantitative, and data levels, levels that don't give us a lot of information like nominal, and like ratio where we get a lot of information. Let's start with data timing. Time series data are data where we've looked at a particular value and collected it over multiple time periods. So I use the example here in the slide, stock price on a daily basis for a year. So we might be trying to study Apple stock, for example. And we're looking at the stock price every day, maybe the closing stock price every day for a year. So we'd have a whole bunch of rows in the spreadsheet, and each row would be a different day of that given stock price. Cross-sectional data is data at a given point in time collected across multiple variables. So the bank might be interested in analyzing all of its loan customers at a given point in time. So the bank can run a report that prints out all of the different loan customers and their loan balances right now. That would be cross-sectional data because it's what's happening right now at this one point in time across multiple customers in this case. So here's a picture to kind of help you see this. We've got sales figures for a company. The blue circle represents a time series data set. We see Atlanta's sales in multiple time periods. In fact, each of these rows, if we went across Boston, that would also represent a time series data set. Now, the red circle represents a cross-sectional data set because it shows multiple variables, Atlanta's sales, Boston's sales, and so on, in a given time period. So yeah, as you look across the table, there are multiple sets of cross-sectional data. Each year is a cross-section of the company's data. Something I would never ask you about, but because we have multiple variables across multiple years, there's actually a special name for that. That's called panel data. Data can be quantitative or qualitative. Quantitative is variables where the values are really actually numbers. Not just numbers that we've used to represent categories, but really numbers. So dollars would be a quantitative variable, the number of children, and so on. Quantitative data can be broken up into two categories, discrete and continuous. Discrete data is data where the options that could be reported on a variable are countable. So I give the example of the number of children. The neighborhood I lived in Salt Lake before I came to Illinois to start teaching here, there was some households in our neighborhood that had 0 children. There were some households that had 1. We had 2 in our household, and there was a household down the road that had 14. But it's a countable number of children, whole number and countable. Some people joke about having a bun in the oven. They'll say, oh yeah, we have 1.5 kids because they have a kid on the way. Well, really, you have 1 kid or you have 2 kids, right? So it's discrete, it's countable. Continuous variables, on the other hand, have infinitely many values that people could provide. So we've got weight and volume listed here as some examples. Weight, actually, we could record to maybe the 3rd decimal place with equipment that we've got here in the physics department. So we could take you downstairs and find out that you weigh 152.469. There'd be lots and lots and lots of values if we could measure to that level of precision. So discrete is countable, continuous is infinitely many possible values. Qualitative data is data that are really categorical. They don't actually have a true number associated with them. We're going to probably assign them numbers oftentimes to make it easier to summarize the data. Some examples of qualitative data are marital status, political affiliation, eye color. Those things are inherently categorical, so they're qualitative data. When we record them in the spreadsheet, we might put numbers associated with them, but because those numbers really represent these words, we're going to call that qualitative data. The book provides this nice picture so that we can see the data levels and understand this sort of food chain of data. Nominal data is the lowest level of data. What it does is allow us to do very basic kinds of things. It's categorical data, and it's categories where there isn't even any order, where order doesn't even matter. So I use here examples of ID numbers, gender, eye color, political affiliation. All of those things would be nominal data. They're categories that allow us to do a little bit of analysis, but not very much. So Coke versus Pepsi, right? Categorical data that doesn't even have any ranking associated with it. Ordinal data. Ordinal data is data that has a natural order to it and its categories. So we could talk about age groups, ages 18 to 24, ages 25 to 34, and so on. We could talk about what class somebody is. Freshman, sophomore, junior, senior. You guys know that there's a significant difference between being a freshman and a sophomore. By the time you get to be a sophomore, you know some stuff. You got some stuff figured out. It's certainly a lot better to be a sophomore than it is to be a freshman. So ordinal data, where the ranking of those categories really matters. Another thing that we're going to put into that category of ordinal data is the Likert scale. The Likert scale is how much you agree or disagree with a statement. So strongly disagree, disagree, neutral, agree, strongly agree. That would be an example of a Likert scale, and it's also ordinal. It allows us to do a little bit higher level analysis. Then we've got ratio and interval data. These are data that are truly numerical, and they tell us a lot more about what's going on. So I use the examples on the left of temperature and dollars. Now, the book spends a significant amount of time trying to explain the difference between interval and ratio data, so I'm not going to talk about that a lot here. But interval data are data that do not have a true zero. So when we say it's 0 degrees outside, that doesn't mean much, except for that it's really cold because it's colder than 32 and 32 is freezing. Ratio data, that 0 really means something. If you engaged in a business transaction and you earned $0, that means something. That means you didn't make any money, and we know what that $0 means. So that's the difference between ratio and interval. Now, the steps to categorizing data. So when you open a new data set, you're going to want to take a little bit of time to look at the data, because it's data you've never seen before, and get familiar with what kind of data are in the data set. So I put here the steps that the book lists out. Identify each factor in the data set. Each factor, that just really means pick out the variables. See that you can see what variables there are in the data set. Determine if the data are time series or cross-sectional. So as we look down the data, we're going to look to see, is it the same variable being recorded again and again in different time periods? Or is it one variable being measured in multiple locations or across multiple people or multiple businesses or something like that? Determine which factors are quantitative and which are qualitative. Sometimes we're going to open a data set and it's going to look like everything in the data set is quantitative. But remember, if that data has numbers in it, but those numbers just represent categories like marital status, then that data is actually qualitative. And then determine the level of measurement. Remember, nominal, ordinal, and so on there. So here's an example of a data set. This data set's available to you on Moodle, so you can open this up. It's called Colleges and Universities. This data is cross-sectional. I can tell that as I open this up, it's multiple colleges being measured here on a bunch of different variables. I don't see time periods anywhere in here, so this has to be cross-sectional data. Also, I can see words here, so that's qualitative. Abbreviations here, also qualitative. And then this looks like it might be quantitative data, but actually 1 represents public institutions and 2 represents private institutions. So any 1s and 2s in this column are really still just categorical data that we've put a number on so that we could make a graph out of them. Now as we go across here, we've got math SAT, verbal SAT, the number of applications, the number. These are all numbers that have true meaning for those colleges. Some of this is interval data. Some of this is ratio level data. So the math SAT and verbal SAT are actually interval data. The SAT does not give out a 0 on the SAT. They give out something bigger than 0, and then the bigger the score, the better you did on the exam. It's the same as the ACT. Many of you might have taken the ACT. The ACT has a minimum of a 12 that they give on a section of the exam, and then the scores go up from there up to a maximum of 36. And the higher your score, the better you did on that particular test. The number of applications received, though, that would be ratio level data, because that number could be 0. There is the possibility that a college did not get any applications. So we've got quantitative data that are interval and ratio.